Time now to take a look at the world of delivering on the value of our biggest and best ideas, the world of projects, programs, production. Exploring design, managing build, testing quality, and deploying for value realization. But before we get into the detail of the planning and performance of work, let's see what we can learn from the laws of supply and demand. Above is a graphic representation from a real case of just how little of our paid-for capacity is actually doing work. The green bars represent paid-for positions, and the blue bars the summed-up load driven by the work schedules. Let's get a little clearer at just what we're looking at in the previous slide by looking closer at what we mean by positions and assignments. What we mean by a position is a role in a project which has a budget approved with an expectation of a start and an end date. The burn rate multiplied by the duration of the position gives the total burn. Assignments are created when an assignee is recruited into a vacant position. In most cases, when someone joins a project, there is an induction period before useful work can be done. This so-called useful work is articulated in blue, and we call it the scheduled load. It is the load that comes from the systems and tools used for work management. You can see that in this example it doesn't ever quite reach the normal capacity of an 8-hour day. And it certainly doesn't require any sprint capacity, such as overtime or weekend work, to satisfy the demand. Incidentally, running at sprint capacity the whole time is a recipe for burnout. So what then is the optimum number when we look at load versus capacity, or put another way, demand versus supply? Typically, the staffing or resource plan of a project will have the positions we've previously described as the rows in a spreadsheet. There will typically be a column for the role with the name of the resource type, such as analyst, developer, tester, engineer. And next to each, in another column, will be the name of the person assigned to the position, what we call the assignee. Move along another column, and there will be a dollar value as to the daily burn rate for the assignee. And then there will be a whole lot of columns off to the right, starting with the start date and increasing in weekly increments. At the right-hand edge of the spreadsheet will be the last date column, marking the position end. Let's take a look again at our previous graph, which is the aggregated view of all positions for a given phase of a project. What it shows is that on average, the schedule density is running at a mere 34% of the total capacity available. Let me put that another way. The total hours of load, as articulated by the various detailed schedules developed in the project, were running at an average of only 34% of the total hours paid for by the project. This means that almost 2/3 of the available capacity is not doing any value-added work. You may think this number is very poor and that you could do better, but I can assure you it was from a top-performing, world-class global project. Most projects I know wouldn't know where to start even making the measure, such as the ill discipline around the science and art of quantitative work management. When I first discovered this fact, I was stunned, and it reminded me of Taichi Ono, the famous guru of the Toyota production system. He observed that whilst a particular component they made might take a matter of minutes of machining time, they would often have months of inventory of the component. The obvious question to be asked in both the production and project cases is how to get rid of such waste.